Okay. The zone 3 also can be calculated in this way that zone 3 is the total of the first transmission line plus 120% of the next longest transmission line, correct? Longest transmission line, and you have everything by here. Okay. Then the next important which you use, you can go through this example by yourself. The next important you use is find out the in-feed current. Okay, what is the in-feed current in this relay? Assume the transmission line. Assume this transmission line without considering this one. Okay, assume this one not existed at the moment. Okay, so there is no IB by here. When we put a relay at this point, a distance relay at this point, okay, any fault in front of this one can be measured using this relay V over I, correct? Then the voltage at this point, the voltage at this point is fed this one, and the current also, this is the CT feeding this one. So the current is only IA. So V over I. On the other way, we can represent it as a VA, which is at this point, over IA, correct? But if we add this relay, okay, if we add this relay, up to this point, the only current is IA, but after this point, the IB also added to this current, correct? We can set based on the Ohm's law and the KVL VA voltage at this point is IAZA, the impedance of this transmission line times IA plus IB times ZB. ZB is the impedance of the bus B until the fault point. On the other way, since our relay is set at this point, okay, we are still having the Z of Z, this Z, okay? The Z is coming from this point. So if you divide all of this by IA, become VA over IA ZA plus 1 plus IB over IA ZB. Okay, right now consider this equation. If IA is bigger than IB, if IA is equal IB, and if IA is less than IB. Okay? Without having IB, the impedance VA without having IB, removing this one, all this, correct? This one must be removed, this one must be removed. VA over IA for a fault at the point F is ZA plus ZB, correct? Okay, right now look at this equation again, the new equation again, this one. If IA is bigger than IB, assume IA is 2 and IB is 1. So 2 over 1 is 2. 1 plus 2 is 3. 3 times ZB, is it equal this one? It is not. Okay, right now, change the idea. IA equal IB. So this is become 1. 1 plus 1 become 2. Again, it's not. Last one, IA less than IB, IA less than, I think I evaluate all wrongly. So, no, correct. IB is 0.5, assume, or 1. IA is 2, okay? So become half, correct? 1.5. So 1.5 times ZB, again, is bigger than this one. So it means that we face underreach in this in-feed condition. So how we should remove the in-feed condition? Okay, for removing the in-feed condition, you have to calculate the K factor. K factor is coming in this way. All the currents feeding the fault point in the same way as the normal current, which is IA. So IA this way, correct? So IB also add from this one and feeding. Cannot coming from other way. Okay, this one is not accepted. So all the k are that one, the fault of the current of the new generator or new points added to the normal relay current. So let's see this example. Okay, this is the example for you. Assume we have a fault at this point and relay is here. So IC is coming here, correct? What else we have? What else feeding the fault point? IE also coming, correct? IA from this relay coming, and IF also. So the K factor for here is IF, IF, IE, and IA. IF, IE plus IA over fault at the relay, sorry, the current at the relay point. At this moment, at this point, we no need to consider the ID. Why? Because the way is on the other way. Also, IG and IH are add up to each other and make IF. So no need to consider. IF is the assumption of that one. So K1, which is coming for zone 2. Now, how we calculate this is zone 1. Let me go back. Okay, this is zone 1, correct? The 80% of this one. Then assume this is the next shortest line. This point is the next shortest line based on the second regulatory. So you can see 0.5%, 50%, 1 plus K1 ZBD, okay? And the K1 is IAIEIF as I calculate by here. IAIEIF. Then again, assume the second, this is zone 2. Zone 3, assume zone 3, the fault executed by here, which is next, what we should have, okay, it is full of this one. Then next longest, okay, this is for K2, and K3 is coming at this point, okay, K3 is coming at this point, next shortest, don't forget, okay. First, calculate K2. How we should calculate K2? It's coming in this way, okay. So ID is coming, correct, because IC is on this way. IC first, IC, I'll show you IC, okay, IC is this way. So ID, IE and IA both coming, correct, to this point. Anything else, IF is not on that way. So this one, AED, yeah, you can see all this added to that point. So it calculates the K2, and for the K3 is coming in that way. Let me first clear this part. Okay, so this is the fault point. So for this one, IC is coming in this way, correct? So the other faults, this one coming, this one also coming, this one also coming, and then IH is from this way, but IG is coming. So you can see IAED and G for that purpose is there. And then you can see it's K is for the second part, and this is based on the second regulatory. Total of this 100% of next longest line and next shortest line 25%. Okay, last of last is example 9.1. For that purpose, assume this is our transmission line. You can see the relay is set at this point. Okay, this is the relay point, and this is the fault current of this system. You can see by this one. Okay, so first, we have to consider 80% or 85% of the positive sequence. Don't forget positive sequence. We only focus in this unit on power protection, only positive sequence. So 80% of this one you can calculate. And then For the next is next 50% of the next shortest line. So let's see which one is the shortest. 0.75, of course 5 is bigger. 8, of course, is still this one. So next shortest line is this one. So this is the next shortest line. Then you can calculate the zone 2 as a main, so Z1, Z10 to 11, impedance of plus 10 to 11 plus 50% of 11 to this point, correct? 11 to the point X. I'll show you by X. Okay, then how we should find out the K1. So the K1 is here, next slide. The K1 is at this point, correct? So this is the relay point. So this current, of course, coming. This is opposite, no need to consider. So which one must be considered? Okay, this one is 1, must be added. This one also must be added, but it's 0. Okay, of course, no need to. This one also coming, and this is the last one comes in. So you can see this one is the first, this one, then 0, then 5. Where is 5? Yeah, 5 and 40, 449. 449 is this one kiloamp. They convert it to the normal amp. And finally they calculate this impedance, and do not forget here is 3.34 suddenly become 4 point. Why this one happened? Because of the formula. The formula for this one is 1 plus k1, 1 plus k2, 1 plus k3. So the 1 is added to that one, and calculation is done. Then zone 2, for the zone 2 we should consider the fault at these points. Okay, zone 2 is calculated. Zone 3, sorry. Zone 3, for the zone 3, we must consider the next, okay, here. The next, the total transmission line, correct? Next longest, so next longest is this one. And after that, 25% of this one. So since the transformer here is the value given, the impedance of transformer, we assume the same, okay? So the transformer impedance is 11.95 is the angle of 90. So you can, right now, we should find out a fault at this point. It means for find out the K2 and K3, okay? Since this example, and you can use it in your project, even in lab 2, K2 and K3 can be considered as the same constant value. Okay, so just find out the K2. How we should find out the K2 is very easy. So assume a fault is at this point, which is the transformer is here, correct? Okay, so which current feeding? Okay, this is the relay. So this one coming, this one also coming, this one also coming, and this one also coming. Going to this point over this, and this is the value, and the in feed is calculated. Then K2 calculated, assume equal to K3. So you can replace. The final step for this one, we always consider the impedance as the secondary of the relays and secondary of the relays. So we should put the primary impedances, whatever you calculate by here at the last point, you should times it by the CTR, which is the value of the CT. Usually we have as a 5 over 500. You have to calculate this one. You have to calculate this one. Already calculated, okay? Over VTR. The VTR also must be given to you for that purpose. Okay. The next one is a T junction. T junction also coming in the same way as the in-feed current. Assume we have a fault at point F. So first, we protect this line, this part of line, or maybe we're talking with protecting this one. And then by the junction, we have to protect also this part. If the fault happened at this point, again, you can see by the Z1, it's IA and the relay at this point. IA over VA, correct? So we can protect this area. Then for this, for the Z3, we have IB added to that one. So again, we have another in-feed current, which can be seen by this. Okay. So the different technique can be used to overcome that one. Since we don't consider the T-junction for our case, I don't cover. You can do it by yourself and find it out. If you face any problem, please find me. Thank you very much.